Alright, welcome to the last TNS Lunch and Learn series. How many of you are new? Is it 3 of you? Oh yeah, I haven't seen you. The rest of you I have. So anyway, what the TNS Lunch and Learn series is for the last few you that showed up, we're basically taking a survey of, getting a feel for what you guys are interested in. We kind of want to turn this into a class, and we want to know, we definitely need your feedback and any type of additional thoughts to make it better, or things that we're missing, and just trying to gauge the interest. There was 4 other series we did, and this is the very last one. This is the invasive stuff, where I basically destroyed a board. I'm going to go over some techniques. So destructive printed circuit board reverse engineering. Welcome. Oh, my name's Heather. Sorry, my name's Heather. This is Craig. Craig's going to be probably working with me on this class.
I didn't do any of this.
But still. So why do we want to do some of this crazy invasive reverse engineering, where you take the board, essentially pull all the parts off, and try to start to look at the board at a level that not a lot of people are, accustomed to. But so I actually think that people might want to create a netlist of using some image processing. There's a guy at Stanford that did this. I'll show you a couple of slides from his paper. And then you maybe want to view the middle layers, because usually when you have a double layer board, you have the top side and bottom side. You just take off the solder, or you can actually look at the board and visually see how the traces are going between the components. But when there's middle layers, you don't know what's being attached to what, so then that's when you want to kind of grind down and go to the next layer. And the last thing is just, your own personal interest. Let's see what works, and let's see how this goes. So this is the guy, what's his name, Ben Johnson from Stanford, did this in like 2013, I think. So what he basically did was take a board like this with all the components removed, took a picture of it, fed it into his C++ program that used like Open CV, and basically what it did was found all the nets, and it went around, did some boundary scan, and found how these things were connected, which was pretty cool. I wanted to see if we could get this done for our boards, but it's something I'm interested in trying to get done for the actual class. We'll see if we can do it. But so it finds all the nets, and then what it does is it takes these templates, and it does some image processing. It overlays it on top of the board, and it figures out where all these components are. So the left one is for a capacitor, and then the right one's for an IC. So when it does some image processing, all the grayscale part can allow traces to go underneath, so it doesn't really become part of the component, the little component template. The left one, not a lot of times you're never going to really see a trace go underneath a capacitor, so that's why they kind of made that black there. So a typical capacitor layout, you might see something like this, and this particular program actually was the way he designed it. The capacitor can either be lying in 4 different arrangements, well actually 2 different arrangements if there's 2 capacitors. It'll either be this way, like the vertical way, or the horizontal way. And then it's up to the user to go in there and change the orientation to decide which is the actual orientation of the capacitors. It was pretty cool. I wasn't able to find download his program or anything, but it was neat. And this is something that would come out of that program. It would identify all the components where they're at. Here's an example of the capacitors, where you would have an issue, and you would have more components in your net list than there actually are on the board, and you would have to fix that. But I thought that was cool. Anyway, so moving on. So why are we going to do this? When you want to look at middle layer, this is a cross-sectional view of a multi-layer board. There's 4 layers in this. You can see the copper, top, middle, and the bottom. So we found a board. It's actually up here. I'll show it to you when we're getting to the end. But it's actually doable. So how are we going to do this? Well, I went on YouTube and I looked at a bunch of videos, seeing all these people saying like, oh, this is good, use this, use sanding paper and all these other types of tools. I was like, well, it looks really fun and, you know, dandy. Let's see if we can do it. So the bare necessities at this point is you're going to need some gloves, mask, and some sort of rotary tool. I used the Ryobi tool back there. And other things you might need, this really came in handy. It's actually, they call it a flex shaft. You just attach it to the end and it allows you to, you know, gives you more leeway and more directional stuff when you're trying to like actually start sanding down. Definitely need a magnifying glass. These clippers are really nice, the cutters, pliers, and then the normal little tiny tweezers you get there. Because like when you get down on the board and you start removing those little tiny capacitors, it's a pain in the ass. So the other thing you would need is a hot air gun and possibly a soldering station and Homer screaming in the background. So some of the attachments that I looked at when I was working on this was sanding bands, sanding discs, flat wheel, abrasive buffs, detail abrasive buffs, and a lot of sandpaper. There's other types of techniques, I mean, other methods you can use, like one of the other guy, what's his name, Joe Grant, actually tried to use a fiberglass scratch brush. I wasn't really going to go down that route because it's a little tiny pin, you got a lot of space to cover. So I'm not going to do it. A utility knife, you can use that, but it's really abrasive when you try to like start etching off the solder mask. It's just not going to work. Toxic chemicals, couldn't do it in the building, but something we might consider trying for the class. Just it won't be in here; it might be outside, or trying to show you guys how it might work. And other really high cost, low return solutions like, you know, CNC milling, sand blasting. What was the other one? Laser ablation. It's crazy, but I mean, if you have the money and you want to get it and try it, go for it, but we can't do it. So to try to figure out what would work and what didn't work, I basically took his little Gumby board and I was like, well, this is only two layers, like one on top, one on bottom, that's it. It's actually single, but no, it's not, it's two layer. It's two layer, because I was like, I'm looking at both sides. So I just wanted to see what was going to take it off and what wasn't going to be too abrasive where it like ate up the copper and then I couldn't even take a picture. Because in the back of my mind, I'm thinking, well, I need to make sure that I can preserve the copper so that I can do some of that image processing at the end. If I like eat away at the copper and some of the traces are gone, and that kind of defeats the purpose. So I started with the sanding band. This was a pain in the butt. So the sanding band is not great. So this very first picture was when I did not have that extension, the extender on the rotary tool, and it's really hard to keep it like parallel with the board. So then the band just kind of like goes along, and it kind of actually ate up the sides of the board. If you look down here, you'll see it on a lot of pictures. And then the really light gray spot up there, it just started eating away, and I was like, that's not good. So you can adjust the RPMs, speed of the sanding band, but the slower you go, the more it gets caught on the board, and then the faster you go, the faster it just eats down into the copper. It's not great. So I was like, well, let's try slower. You go slower, and you can start to cover some ground, but then when you get to the edge, this is when I attach the flex band. But you start to get the same sort of issues. You're going to start eating down to stuff quickly. So it's not something I would recommend when you want to keep your copper around. I don't like it. I don't recommend it. You'll see. I tried to use it again later on the actual board. The actual router board. So this is what happens. There's a lot of there's going to be a lot of debris. A lot. Depends on which ones you use. So the sanding band wasn't bad, but because you're going to get a lot of copper flying off sometimes, you get copper sheet here. That's what the gray or the gold tannish colors are. So the funny thing is that this board was the solder mask was black, so I couldn't really tell. You'll see a lot of black powder on the edge. some stuff. But when you start working with the actual board, where it's the green stuff, you can start to see this. The next one is the flat wheel. The flat wheel is kind of nice. I didn't really like it for taking off the solder mask on the very top, but what it's really good for is when you need to get off the copper. And then you kind of have to apply a little bit of pressure, and you'll hear like some zzz, and then it kind of like starts to shave it away for you. And it was really nice because then that's how I got to the middle layers. But I don't recommend using it at a high speed, because at a high speed, you have no control over it. It just runs off the board, and you just kind of have to keep it down. But then when you try to hold it in one place, you can't really tell where you're at relative to like where it's grinding at. You kind of just move it around, and then it gets away from you. And this is what can happen. See, it took away the copper here. This was fast, at a fast speed. The previous picture here, this is at a lower speed. When I mean lower, I think I had it at a 3, and then the second one is when I had it at a 5. So the fastest it could go was 35,000 RPMs or something like that. Oh, and that particular one goes from 10,000 RPMs to 35,000. So I think that's the typical range of what you're going to find with rotary tools. The next one I started to look at after the flat wheel is like, well, we are going too abrasive with the sanding bands and the flat wheel. The flat wheel is basically just a lot of sandpaper, like stuck together, like in a nice little fan shape, which is kind of cool. And they come in different grits, and I'll talk about the grits in a little bit. But these also come in different types of grits too. But this came in this real nice pack that I bought at Lowe's. So that's how I was able to just pick out which one I want to try and stuff. So this particular one came with these two. This comes as a pack. This is not sold individually. You're never going to get this guy by itself. This guy's really nice. The other two are just, they don't work too well. And I can't really tell which one is which, because this tells me it's there's I think it was an 80 grit and a 120 grit. So I can't tell which one's which. I was kind of like trying to touch it, and it didn't really, stand out. But so the very first thing is this one failed because, can you see up in the right-hand corner? Do you see how it just ate away? It's this little guy. There's nothing left. So I was like, what the hell happened? I was like, those guys on YouTube, their buff lasted forever. What's wrong with this one? So what happened was I was running it at a speed it shouldn't be run at. So when I went back to Dremel, I took a look at all the speeds that you can actually run these things at, what the max is. So the maximum for this particular finishing abrasive buffs was the 20,000 RPMs. So if I'm running like at 3 or anywhere 3 and above, you're running, pretty high. And I was like, oops, that wasn't right. So I had to go back and try it at a lower speed. But so then I was like, well, let me check my other ones and see how fast I can run those at to make sure I'm running at the right speed. And then after a while, I looked at the little package. You open it up, it says it right here in the front, how fast you can run it. I was like, oops, should have read the directions. So sanding bands you can use it as high as you want, up to 35,000, depending on what you're trying to, so copper's right here. It's 25 to 35,000 RPMs. Where's the other one? The sanding discs, 10,000 to 15,000, and then the flat wheel's 30 to 35,000. It'll definitely eat away with it really quick, but you got to be careful. So tried it again. This is this other guy. So remember I was showing you the two pictures that come in two different, there was the one that came as a pair and the other one that came as a thing by itself. The one by itself was it was a 220. No, sorry. Oh, I can't remember. I think it's like a 320 grit or something. It's really soft. It's not very abrasive. So I started running it and at the recommended speed, and it didn't even do anything to the top. It didn't even eat through part of it. It just kind of like buffed it up for me, and I was like, that's not right. And so it wasn't doing anything. And I got closer, I turned it off. I was like, let me see how this brush is doing. And it just started getting worse and worse. I was like, you know what, I'm just gonna stop. It's not doing anything. So we just decided it wasn't gonna work anymore. So what I found out is that, you know, one that works is that the two that come in a pair, but the gold one is much nicer. That's the lighter color of the two. That's the best one you can find. But they're kind of expensive, but I mean, you're not gonna be like taking apart 5 boards or anything. So it's gonna be one board you're working on or something, you know, in a small quantity. So you're not gonna need too many of these buffers. But what I found really nice is that you don't want to be using this to eat away at the very, very top layer. You wanna kind of like wait till after you get off the very top layer of the solder mask, and then just kind of like see some copper, and then start to use this buff to get rid of the next stage. And it's gonna leave behind this, and you see that you have all the copper left, none of the copper is getting eaten away. So I was like, well, I don't wanna use my you know, those abrasive buffs to like eat away at everything. Let's see if we can figure out a way to get rid of the top, and then take the buffer and use the buffer to get next to the copper. But we don't want something that's too abrasive, like the sanding band or the flap wheel. So I was like, well, I was able to take some normal sandpaper and start to rub it away. Let's try the sanding discs. So I take the sanding discs and trying to see how far down we can go before we start to, like, you know, mess up some stuff. And I took the same sort of approach, you know, 3 on the right, 5 on the left. The 3 is really nice. It didn't eat up too much, but it leaves behind these nasty cuts in the copper. You can see the rotational thing. And then the same thing on this side. This particular tool was pretty nice, but it also has the same tendency to run off the board. And then you can't really tell where on the board that you're moving it around. It's kind of hard. I mean, if you're down there, you're starting to get all that dust in your face, or the solder stuff that's coming out, the debris anyway. When you get towards the edges, you start to eat away at the copper on the sides. And I didn't really want that. I wanted to try to keep everything intact. So, it was supposed to be a zoomed in picture, but that's essentially what happened, is it's starting to eat away at the sides. And this is a more zoomed in view of what was happening with the cuts it's leaving in the copper. So on the back side, I was like, well, let's try this at a slower than 3, like probably about 2.5, 2. It was nice. Not a whole lot of copper went away, just on the edges. But there's a lot of this spin, like circular stuff that's going on, which is fine. But then sometimes, you know, I don't know how image processing is going to fare when we get something like that and we take a picture of it. Is it actually going to pick up those lines or not? But we'll see. So then I was like, well, let's just go to pure sanding paper. Let's just, you know, take the smaller road and say, let's just try all the sanding paper. So I have 80, 120, 220, and then this aluminum oxide, which is at 150. So there's all these different grains and stuff. So the lower the number, the more coarse and abrasive, like thick harsh it's going to be, and then the higher the number, the more fine it's going to be. So here's an example from the right to the left. The one on the far right is an 80 coarse, and then the 120, and then the 220, and then the aluminum oxide over on the left side. So if you just looking at it like this, the very fine one is pretty nice. It's not cutting into your copper too much, and it's leaving a fairly decent finish. The only problem is that, like with everything else, you know, when you're pushing on it, you don't really, you can push and push and push, but then you find that you're rubbing in the same place. And then when you're rubbing off all that, the black stuff, the solder mask, it's definitely kind of hard. And then you try to get the little pieces off, and it just doesn't, you can do it, but it's, when you're trying to take care of the copper, it's hard. I don't like it. So I was like, well, we'll try a different way. But here is the 80 grit zoomed in a little bit. It's got a lot of scratches in it. And I think another thing too, it took off the solder mask pretty well. This is the 120. It has a little bit of scratches, but not too many. Not as much as the 80. And this is the 220. You don't see a whole lot. It's not cutting down into the copper too much. And then, so the last thing I tried was the detailed brush, which is this. I like this guy. This guy's cool. So this pack came with two different ones. I mean, two other detail brushes, but this is my favorite. This is the first one I tried, and I never went to another one. So there's like other, they also come in different grits too. So it all depends on what you're doing, but I think the one I was using was a 120. Yeah, I think it was a 120 grit. This is the picture. So what I did with this is that you don't want to use this at the very, very top. But what I did was, well, I can use the buff to get down to something like this, and then I don't want to, I have all this leftover solder mask. So what I did is I took that detail brush and just kind of like went across the copper and got rid of all the black stuff. And then it did really nice. It won't even really eat into your copper at all. It just kind of like brushes away whatever's left on top. So what I did was like, well, now that we kind of have an idea of, you know, what works, what doesn't work, how hard you're going to be pushing down on stuff, what, you know, combinations kind of like help with certain situations. So I was like, okay, well, let's try taking this board apart. So this is the top side of this board. This is the bottom side. So I went to work and took all these pieces off. So I was trying to be really nice and keep all the components intact and, you know, heat it up and try to pull it out. It just wasn't working. And I got frustrated. So I just like took the little clippers and just started cutting away everything. And Craig was like, why don't you just cut it away? And I was like, okay, that sounds good. So then I kept working on it, but these little Ethernet, I think they're called the Ethernet 5, these inductors down here, are a pain in the butt. So I couldn't get it off. I tried to clamp it off and it wouldn't come off, and I got mad. So I took the Dremel and I was like, I'm gonna cut you off. So I took the Dremel and I just like sawed right into it, and it was awesome. It was so, the pressure was all relieved after. So and then it's easy. Once you get the cap off, you can pull those black things up, and then once you get that out, you can flip the board over and heat it with a heat gun on the other side and just pull the wires out. That was the easiest way to get it off. And then just using the heat gun to remove all the little capacitors. That's what I used the tweezers for, and the magnifying glass, heat it up and then just start rubbing away at it, and then they all come off. This one was kind of hard to take off. The heat sink here. There's like 4 little sections where it's going like a through hole. You kind of have to heat up one side. What I found really nice is that if you just take off the solder and then pull up, it works. And then heat the other side and kind of like peel it back, and it comes off. And then I got everything off. Actually, I got everything off. Yep. So I took everything off. It was all fine and dandy. So I was like, okay, well, let's get to work. Let's try this. So I really like this particular combination. So what I do is I take the very top and I use the sanding disc. The sanding disc comes in different types of grits. So the ones I used on the blackboards were the 120, which is kind of like the middle of the road, and then the 240. Because I didn't know how thick this solder mask was going to be, and I didn't want to damage the copper. I was like, this is the first go around, so I'm going to take the 240. So I took the 240 and I started taking away the top part. I was like, let's get this off. So taking the top part, getting away. See, I went down as far as I could to the point where I could see some copper and where I wasn't like, you know, taking away too much. And then the next thing, oh wait, what happened? Why is it broken? Oh, there. Did I have to? No? Okay. So the next thing, after you do the sanding paper, you can take this one. It goes faster. You can actually take the sanding paper, but it takes a long time. You just keep rubbing forever. And I don't have that much patience. So I just took the sanding disc, ran it across, and then I was like, all right, well, let's just clean it up with some sanding paper in the middle to see where we're at. So you take sanding paper and then you do the buff afterwards, that abrasive buff, you take it and you just start rubbing it across, and it starts to eat away at the top again. And then I was like, all right, this isn't taking too long. Then we took the I think it's 180, yeah, this guy, 180, it's another sanding block, and just start rubbing it again. And then we got to this point, and then I was like, all right, let's do the 220 to get the next layer off. And we got to a 220, and I was like, well, let's try the buffer again. We took the buffer, and we got from this point to here. And now we have just these little tiny pieces. Do you remember like what we saw on the black one? These little tiny like hints of solder mask. So then I took the this guy, the detail brush, which is this one, and that actually cleaned it all up, and it left the copper behind. And it looks pretty nice. I was going to show you this, but don't want to spoil it, I guess. But it leaves everything behind. So I didn't get to this corner because it's holding it down, but eventually I'll go back and try and get it off. But it's pretty nice. All the copper was left, nothing. I took a picture of it, and then I was like, all right, well, let's see if there's anything underneath there. So I took the sandy bands on the right-hand side. I started eating away at the copper. It wasn't going very well because I was like, well, the sanding bands are terrible, but let's see if it will eat through the copper. And it wasn't nice. It wasn't giving me a uniform look. So I was like, well, fine, I'll take the flap wheel. So I took the flap wheel and just started, eating away at it. And it's really nice, but you have to push down hard on it and then pull it across. And eventually it came off. And then I just took some sanding paper to get the rest of the copper that was there, because I kind of want to keep what's underneath it there. So eventually, what did I use here? The buffer, the abrasive buffer. When you use the abrasive buffer, you can get this off, and then you use the buffer, this guy, the abrasive buff, and then you follow it up with this one. And then you get to this. This is the second layer of copper on the right. You see, this is the middle section, which is the little type of substrate that was left behind. And then you have the copper that's underneath that. And then if you go again, keep going, eventually you get to the FR4 that's in the middle, that's separating the two sides. And that's all I have, actually, because I wasn't able to put all of my slides together. But here's the board, if you guys want to take a look at it. So I was going to let you guys play with some stuff, but there's a lot of people here. So if you're interested, you want to stick around and see how it looks, I can show you. But I find that at the very, very least, I think I would recommend, some sanding paper and these guys. So I started off with the sanding disc. This is good. Take off the top part. Start with either 120 or 240. Don't go any high. Don't go any lower than that, because it just eats everything up. And then use this guy, the abrasive buff, and then sand it down a bit, and then finish it up with this guy, the detail brush. This one will take off those little tiny blemishes that are left behind. It kind of annoyed me, but you could leave it on there if you want. But if you want a really nice picture, I would definitely recommend it. And then after that, if you want to go down several layers, definitely use the flap wheel. It's like the fastest thing next to sanding, but you want to sand every now and then just to make sure like what layer you're at. But other than that, that's pretty much it. So that's all I have for this section. Anyway, have any questions? Comments, concerns? Yeah?
Can you just, so I'm not familiar with the hardware part, but can you explain the processes in terms of after you take a picture, like what you do with that picture,
To create an atlas? The idea is that we would take the picture and there would be several layers, right? and then you would have to, you had to write the program and the algorithms to be able to match up those through holes. Once you match up the through holes, then you're supposed to be able to, connect the net list. There's going to be a net list for each layer, and you take those net lists and, automatically you're going to figure out which one's matching up to which. So in the Ben Johnson stuff, he said that his multi-layer thing wasn't really working very well, but for 2 layers it was fine, but he couldn't really, it was hit or miss. Some of his connections between the layers were incorrect. So there's like some tweaking he had to do in his algorithms, but
So
I mean, that's the idea.
Yeah, if you don't mind doing a more manual process, if you get good pictures of each layer, like so you get a picture of the first
Yeah,
layer,
then-
the whole layer, you can put them on like those clear overlays, like the old school projectors.
Yeah.
And then you can just physically overlay them on top of each other and visually look to see where things are connected. So it's a bit more tedious, but
It's doable. Yeah, you can take the what's it, kind of like a high contrast thing, where the traces come out to be white and then the background's black. Yeah, definitely can do that. Or vice versa, black traces, white background, overhead thing. So old school, but that would work. Pretty nice. Yep. Any other questions? Yeah.
So what are some of the situations where you would want to do this? In the end, your board's kind of destroyed.
Right. So that's that's the other thing. That's the very first beginning thing.
To like $100,000 piece of
No. No, I think I think most of the time, I mean, the only time I would do this is if you couldn't get, an idea of how things were connected. Like you'd have no idea how things are working. You couldn't find firmware or something like that. And, you really need that schematic completed. And the only way you can is if you get to the middle layers and take pictures of how things are connected in those layers that you can't see. That's the only time I see you wanting to do something like this. Or just to have fun, but.
You know what they're going to do this for some of the old systems that they don't necessarily have all documentation stuff for.
Right.
So like taking old, like the A10s and taking old systems and then putting them on a single chip. They did a lot of the stuff where they just corrupted stuff and they go down to their level and you figure out everything. So that's something that
sometimes you really just want to take off the top solder mask. So if you have a trace connecting 2 parts, but maybe they're BGA, so you can't get to the pins, but you want to sniff the traffic there, you just want to take off that top layer to get to the copper trace, and you can tap on the copper trace. So a little less involved,
But you wouldn't be taking off all the
right,
components. You'd be just
taking off the
etching one part, but yeah. But when you have the components on and you're using these tools, that's going to be a little bit different. It's definitely going to be something you're doing by hand and using tweezers and little things like that. Yep.
So like what percentage of the boards do you find that it could be useful, like
Percentage of the boards? Well,
Well, I mean, as in this doesn't work at all, or it's just
like
not
where
used
you have to
doing it?
you have to go through this last step.
I'd say very rarely.
I don't see us doing
I don't
this
think
to.
I've ever had to do it.
I don't see us doing this to any of our boards back there, but I mean, it's something that at least how you would approach the problem and how it would work, what type of tools you would need to do it. But yeah.
So it's like an all else fails.
Yes.
You really need to know that.
Yep. I need to know. I need to know what's down there, right?
And hopefully you have more than one.
Exactly. You should definitely have more than one board because none of the parts. If you look back there, we're not putting it back together. It's not being put back together.
But if you reverse all of this, you can just have your own boards made. So
Right.
Build a replacement.
Build a replacement. We could do that. We could make more boards. We should do that to the Apple phone. Let's make our own Apple phones. Yep. So, anything else? Any other questions? I wish I finished up the slides better, but I just finished the second part when I was this morning. But it's definitely flimsier on the right-hand side or the left-hand side, depending on how you're holding it. It's much thinner. So you actually know when you get to the middle, when you start sanding it, it just falls off. You're like, oops, I'm in the middle. Yep. It's pretty cool though.
that was like 4 layers altogether.
Yeah, there's two on the other side. So I was gonna check it, but
It's actually got, this board has it, not all of them do, but if you look in the corner, there's little numbers 1, 2, 3, 4, and that's actually printed on the copper in each layer. So if you look on one side, you can see the 1 and the 2, and you flip it over to the other side, you can see the 3 and the 4 through the fiberglass layers. So you can see that one right there. And it's nice for them to tell you.
yeah.
But
Right.
you don't really expect it.
Yep. Any other questions? Is there anything else you wanted to see besides this? Because this is sort of the idea of what we had for this last invasive stuff. Getting down into the copper mess.
What would the layers end up being? Would it end up being like 2 layers of actual like routes and then a power and ground layer? Typically it's like a 4-layer PCB.
So, I mean, you can see this one actually has like traces in that layer beneath. So I
Yeah,
don't
so if you go back, so you go
think
back,
they
here you go.
factor.
This one has layers. I mean, this has traces in it. This is the traces in the second layer. This is not from the first to top layer. This in the middle is the little separator. I don't know what this is. Is this like some sort of substrate, or is it fiberglass? It wasn't like the middle one.
I don't know.
it was
I
really-
don't work at a PCB.
Yeah, this one was really thin, and it wasn't very. It's definitely. It was definitely more. What do you want to say? It was harder than the one in the middle, the one that's underneath this side. So the one after I took off the copper on top, the stuff that's in the middle just kind of, you just take even the 220 and just rub it, it just dusted off. But this layer took a while to come off. It was definitely much stronger and tougher. It might be just some sort of heat shield that's going between the two copper planes. But definitely the layer that's underneath this one is much softer. And it just rubs off. But there's a lot of it, so you're rubbing forever. I still didn't get all the way through because you can start to see the copper on the other side though. But I don't think, so when you're asking about ground plane, I don't think that was,
Yeah, I don't think they had.
I don't think that's like just one ground plane. I think it's just another section that they're using for connecting the components together, additional traces. I would have to remove everything else to see it, but yeah, just that one side, it just looks like traces.
If you just want that little one, like trace, detail, right?
Yeah, so if you're doing it like just, well, if you're doing what?
Like trying to just tap into one trace. But you can do another one.
You probably could. I never tried this detail brush for like going through the solder. I mean, I can try it, but it might be able to do it. I just didn't want to ruin it because of what was happening with the other buffers and stuff like that. And I noticed that when I rubbed it on top of the copper, it didn't eat through the copper. It was just kind of like brushing away the solder mask and whatever like little types of tiny pieces of debris that was on top. But I have some other. So yeah, here's all my little pieces of Gumby boards that got eaten up.